Hi everyone. Chapter 3 Introduction to Derivatives. Definition of a function. A function f from a set x to a non-empty set y is a relation from x to y such that the following two conditions are satisfied. The domain of f is x. Every element of x is related to exactly one element of y except for the empty function phi mapped to y. We shall deal with only real continuous functions, that is, continuous functions whose domains and codomains are subsets of all real numbers. Classification of functions. Functions can be classified into algebraic function and non-algebraic or transcendental functions. Some algebraic functions, polynomial functions. A polynomial function in one variable x is a function of the form f of x is equal to an x power n plus an minus 1 x power n minus 1 plus etc. a1x plus a0, where a0, a1, a2, etc. an are real numbers and n is a non-negative integer. The following functions are special cases of polynomial function. Constant function. Any function of the form f of x is equal to c is called a constant function, where c is a constant. The constant function is a polynomial function of degree 0 if c not equal to 0, and a polynomial function without degree if c is equal to 0. Linear function. Any function of the form f of x is equal to ax plus b, where a not equal to 0 is called a linear function, which is a polynomial function of degree 1. Quadratic function. Any function of the form f of x is equal to ax square plus bx plus c, where a not equal to 0 is called a quadratic function, which is a polynomial function of degree 2. Some transcendental functions. Trigonometric functions. The following functions are examples of trigonometric functions. F of x is equal to sin x, f of x is equal to cos x, f of x is equal to tan x, f of x is equal to cosecant x, f of x is equal to secant x, f of x is equal to cot x. Logarithmic functions. The following functions are examples of logarithmic function. F of x is equal to log base ax, where a is a positive real number other than 1 and x is positive. F of x is equal to log base ex is equal to ln x, where x is greater than 0. Notice that log base ax is equal to ln x divided by ln a. Exponential functions. The following functions are examples of exponential functions. F of x is equal to e power x, f of x is equal to a power x, where a is a positive real number other than 1. Definition of the derivative. Let y is equal to f of x be a function and let the variable x receive a certain increment delta x, then the function y will receive a certain increment delta y. Thus, for the value of x, we have y is equal to f of x, and for the value of x plus delta x, we have y plus delta y is equal to f of x plus delta x. Thus, the increment delta y is given by delta y is equal to f of x plus delta x minus f of x. Forming the ratio of the increment of the function y to the increment of the variable x, we get delta y by delta x is equal to f of x plus delta x minus f of x divided by delta x. The delta y by delta x is called the average rate of change of function y with respect to the variable x. Delta y by delta x is also called the difference quotient of the function y is equal to f of x. If the limit of this ratio as delta x approaches tends to 0 exists, that is limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x exists, then the function is called differentiable, and the limit delta x tends to 0, delta y by delta x is called the first derivative of the function y is equal to f of x with respect to the variable x, which is denoted by f dash of x, y dash, dy by dx, d by dx of y, d by dx of f, dxf. Differentiation rules. Let f of x and g of x be two differentiable functions in the interval under consideration. Then rule number 1, constant multiple rule. If f of x is a differentiable function of x and c is a constant, then d by dx of c f of x is equal to c into d by dx of f of x. Rule number 2, derivative of the sum. If f of x and g of x be two differentiable functions, then their sum f of x plus g of x is differentiable, and d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. Rule number 3, derivative of the difference. If f of x and g of x be two differentiable functions, then their difference f of x minus g of x is differentiable, and d by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x.